as you start your Desmos.com project where you're going to design your own design on Desmos, I want to review a few concepts with you. We'll go over inverse functions, even and odd functions, how to graph circles and ellipses, and then cover exactly what the project is going to do. Now let's say as part of your project you wanted to take the parent function, which is the square root of x, and just remember the square root of x as a parent looks like this. If you wanted to move it left 4 and up 2, the ordered pair rules for that would be x minus 4, y plus 2, because that's literally what's happening. But in Chapter 3, we should recall that what we do is we go backwards on the x and the same for the y. If you graph that on Desmos, which is here's what I typed into the Desmos calculator, you're going to get this image right here. Now, one of the requirements, because there are 6 on your project, is that you have to have an equation and it's inverse. That'll be worth 10 points of the full 60. To get those 10 points, what you would do is, let's say I wanted to have the red graph here of the square root function on my project, but I wanted the inverse of that function. Recall that the inverse just means flip-flop x and y. So I'm showing you here when I change x and y, you are going to have to give me the final equation, so you do need to show me that you solved it for y. I went into Desmos and took this equation and typed it into the calculator. And what it shows me on Desmos is this blue shape here. It's this complete parabola. Now we do see something a little bit different because our original red graph that we have, we only see part of that. Now the reason we only see this part of the red graph is because we don't have the plus or minus. If we had did the plus or minus, which would be both sides of it, we would actually see this part. So recall, you can visually tell if you have an inverse, if it flips over the line, y equals x. And this line right here that you see is the line y equals x that I typed into Desmos, so I could see that the flip is happening. Now, for many people on their project, they're not going to use the entire pieces of both of these shapes, and you don't have to. What you can do is you can just use pieces of it. Now, the equations you're going to give me on your table of data is going to be this equation and this equation, but maybe of the blue graph, you just want to use this part, and maybe of the red graph, you just want to use that part, which you would use on Desmos, and you would cut it off. And that's fine. I will not look at your picture and see if I see the flip going on. I will look at your 2 mathematical equations to confirm if they are mathematically sound inverses of each other. Now we talked about translating, let's talk about stretching. What if I wanted to take the parent function of y equals x cubed, which I typed into Desmos right here, and I wanted to horizontally stretch it twice and shrink it vertically into thirds. Remember in Chapter 3, what's going to happen to the actual ordered pairs? Well, the x's are going to get 2 times bigger, the y's are going to shrink by 3. To make the equation do that, you always go backwards on the x, so I divided by 2 on the x, and I do exactly what I see for the y. This is just y times 1/3, so that's why I kept the 1/3 here. I typed that equation right here into Desmos and got the orange graph. Now, a second criteria of the 6 you're going to be asked is if each equation is even, odd, or neither. To determine that, you need to remember, odd functions rotate about the origin. Even functions reflect over the y-axis. If they meet neither of these, then it's neither. If you look at the orange graph, you should be able to tell if you hold steady at the origin, you can rotate this. So our particular graph right here is an odd function. So for the project, I would state it as odd. Now keep in mind, you don't have to use the entire graph, you can use a piece of it. So in your drawing, maybe you're just using this little red sector of your function, and that's fine. You would cut it off using Desmos. I would look at the graph on your table of equations and recognize it's an odd function, so you would have to list it as odd. You must look at the complete graph to determine if it's even, odd, or neither. Do not just look at the little portion that you're sectoring out of the picture. Now, a lot of people like to use circles in their drawings. This is the standard format for a circle. This is the formula where HK is the center and R is the radius. So if you wanted to take a circle and have its center be at 5, -3, you put that into the equation backwards. That's what this means right here. So I would do x minus 5 and y plus 3. Then the radius just goes right here and you square it. Now on Desmos, this is exactly what you would type. You could, instead of doing 4 squared, you could type 16, and what it would give you is this graph of the circle. Another very popular shape to draw is an ellipse or an oval. The standard format of an ellipse is what you see here written in the blue. So ignore the purple part for now. It's just the blue part. And if we want our ellipse to have a center at -2, 4, which would be in quadrant 3, I go backwards on x and backwards on y. You actually do the stretch underneath it. So the horizontal stretch, horizontal means the x-axis, so I do that stretch squared. The vertical stretch is 3, which is the y, so I do that squared. You must set this equation equal to 1. This is exactly what you would type into Desmos, and what you would get is the blue outline drawing here. Now, the third of the 6 requirements is you have to have at least 4 inequalities or things shaded or colored on your drawing. Remember, to make something shade or color on graph paper, you use inequality statements. All I would do is go back to Desmos and I would change my equation to the inequality, and it would cause my ellipse, this one in particular doing less than, would cause it to color on the inside. Now, you may not be able to do the coloring on Desmos and keep it there, because if you color, let's say, for example, on the outside of this circle, it might overlap on current graphs that you have and cover them up. So just use Desmos to help you see how you would change the inequality statement to get the coloring you need. What you ultimately will do at the end of the project, you will print off your Desmos picture, get some colored pencils, and show the shading by coloring by hand. So let's just do a quick overview of the project then. Again, there's 6 different criteria that have to be met, each worth 10 points. The first one is what I talked about, the inverse functions. You must have one pair, that means 2 equations in total, of a graph and its particular inverse. That's worth 10 points. The second thing you're scored on is, do you have even, odd, or neither correctly categorized for every single equation? So that's 2, the second of the 6. The third criteria you have to meet is you need to have 3 types of equations. I'm going to ask you the type of each equation. For example, quadratic, linear, absolute value. 3 of those types must be exponential, quadratic, and circular. When it comes to the type, I'm going to caution you. I do have a handout on various parent functions to help you see different shapes. Read the type on the handout or Google it if you're not sure, if you think something is called a certain name. Thing to be very careful about, do not assume you know what a circular function is. We have talked about it. You can see it in the handout, but I will not answer your question if you're right or not. This is for you to determine, so research it and look it up. If you think you know but you're not absolutely sure, double check. And then again, you're going to have the formulas referenced here for circle and ellipse. A hyperbola is just an inside-out ellipse. It looks like 2 parabolas, not really used that often though. The fourth criteria of the 6 that you'll be graded on are the inequalities and equations. You must have at least 4 inequalities, which means you need to be shading at least 4 times. And you must have at least 12 equations. Your equations have to be listed either in standard format, where everything is on one side. For example, the circles and ellipses are a standard format, or you can have it solved for y. Like a line would be y equals 2x plus 1. The fifth criteria of the 6 is grading your domain and ranges if they're adequately stated. And the 6th one is going to be if your equations actually match your picture. Now what you're going to turn in at the end of the project is every single equation listed in the tables with all the good information that I want. The copy of your scoring rubric where you score yourself, and then a printout of your Desmos picture with it colored in where needed. Now, I want to imagine that I'm sketching a bird, and this this red parabola is a picture maybe of the lower body. So in the element within the design, I just highlighted it's the lower body. It does meet the quadratic requirement, so I'm actually going to put it on this particular line. By the way, you may have more than one quadratic. You might have 4. That's fine. The requirement said you need at least 1, so I'm going to put it here so it gets graded as the quadratic. Is this function even or odd? It does reflect over the y-axis, so it's even. You're going to notice here's my equation as you see in Desmos. But I changed my equation to an inequality because I want to shade it and color it red, so I said my shade color was red. The domain of this, to program Desmos to cut my graph off, all you're going to do is you need to find the curly brackets, and then you write an inequality statement. I wanted Desmos to keep it from the x's of -2 to 1, so I had my x's go between -2 and 1, and that is my actual domain. Now the range on this graph is the y's. My range goes from 2 up to 6, so I said y was between 2 and 6. Another example might be that I wanted to do a square root function. Now it's not one of the types I need to have, but it's a shape that I want for my drawing. So I went on to Desmos and I typed in the square root equation right here, where you're going to see I wrote it here. This is solved for y. It's drawn out here in the blue. I can tell it is not an even or an odd, so I put neither. It's called square root. And I'm imagining that it's the tail feather of my bird. Now the domain for this tail feather goes from here at 1 all the way over to 5. So you're going to see that's what I did to cut it off, and I listed the domain between x of 1 and 5. The range is it's as high as 3, and it goes over to 5, so the range is from 3 to 5. I'm going to use this as a feather, and I'm not going to make it an inequality or shade it, so I put no shade color. The final thing for the project is once you have your table put together and everything is complete, again, print out your picture from Desmos and do your necessary shading. Then you want to fill out your rubric. There are the 6 categories. Please do the self-evaluation portion. Again, it's going to be worth 60 points in total. I'm going to take 1/4 of that, so it's a total points of 15 in the test category. The equation in its inverse, if it's there and it's correct, you get 10 points. If you identify it but it's not correct, you will lose 5 points on that. Even and odd, you must have at least one even or one odd function present within your graph. That is one requirement, so it is present. And then they all have to be correct. If any of them are marked incorrectly, you'll start to lose a few points and get down to 8 or 9 points. The equation types, again, you need 3 equation types, and they have to be correct. So if they're present, but maybe you have a couple of them incorrect, you will start to lose a few points. You need the 12 equations, and 4 of those must be inequalities and in the proper format, which means they need to have an equals to in there. You can't have just an expression. You can't put x plus 3. That's not an expression. Y equals x plus 3, that's an equation for a line, and that counts. The domain and ranges must be stated properly in accordance to your picture. Be careful not to reverse those. That does happen sometimes. And the last thing, which is just easy points, is the equations you type into Desmos match the graph. Now, I keep this in here, though, because I want you to make sure of something. When you go to Desmos, there are hundreds of thousands of different drawings there. Do not get hooked on one particular drawing and try to mimic it or copy and paste it. That is plagiarism, and that will get you in trouble. So be very, very cautious not to plagiarize the work that you're seeing there. What I recommend is going to Google or having a design already in your head that you want to do. Look for pictures on Google. See if anything excites you that you want to try to create. Or just come up with your own idea and just start drawing it and start making it. Just be very, very cautious that you do not plagiarize or copy the work that you're finding on Desmos. Good luck, and let me know if you have any questions as you tackle your project.